Hello dear students of class 9, how are you today? I hope you are doing excellent. In today's video, we are going to learn the derivation of Newton's three equations of motion. Well students, there are two ways to derive the Newton's three equation of motion. The first is the algebraic method and the second is the graphical method. In today's video, we will learn only the graphical method of derivation, and in the coming videos we will also learn how we can derive it graphically. Okay, so let's see what are the three equations of motion that we need to derive. The first equation is V is equal to U plus AT. The second equation is S is equal to UT plus half AT square, and the third equation is V square is equal to U square plus 2AS. I hope you are familiar with these symbols. U stands for initial velocity, V stands for final velocity, A stands for acceleration, T is for time, and S is for displacement, not speed. So please be clear with this. So let us see how we can derive the three equations of motion. The first equation of motion is very easy to derive. In fact, to derive the first equation of motion, you just need to remember the definition of what is acceleration. Let us take an example to understand what is acceleration. Let's say we have an object, a minibus on a straight road, and the bus is at rest. In order for the bus to move, the driver has to put on the accelerator. Until the driver puts on the accelerator, you know that the bus is not going to move. So when the bus starts moving from a certain point and moves ahead, the bus is accelerating, means the speed of the bus is changing, the velocity of the bus is changing. So how we can find the change in velocity? Let's say here the initial velocity, I am writing here initial velocity, I am calling it by the symbol U, and after certain time, let's say the bus reaches here and it has got certain speed, I am calling this as final velocity, and the symbol for final velocity we write as V. So what is acceleration? So acceleration is basically, the definition is on your screen. It is simply the rate of change of velocity. The rate of change of velocity. So what is change of velocity? You can see the final velocity is V and the initial velocity is U. So the change of velocity is nothing but final velocity minus initial velocity. Final velocity minus initial velocity. And rate means how fast is the change of velocity happening. That is why we need to divide this whole term by time. So how much time does the object takes to reach V from U? That is the acceleration, and this is what is called acceleration. This is the definition of acceleration. Acceleration is final velocity minus initial velocity divided by how much time it takes. So if I write the symbols for acceleration, we write A, for final velocity it is V, for initial velocity we write U, and for time it is T. So this is basically the first equation of motion, but we can multiply and do some crisscross and can write this equation in a nice way. So let us see how we can represent that. If I multiply here A and T, so this will become AT is equals to V minus U, and if I rearrange, if I take U, if I transpose and take U on the left hand side, I'll get U plus AT is equals to V, and if I interchange left hand side and right hand side, I'll get a beautiful equation, that is V is equals to U plus AT. and this is what is called as Newton's first equation of motion. It is not laws of motion, it is equation of motion. We are writing an equation. This is an equal to sign, right? So V is equals to U plus AT. This is very easy to derive, right? Now there are some variants that we need to remember for first equation of motion. From first equation of motion, this equation A is equals to V minus U by T is very helpful if you want to find acceleration, and V is equals to U plus AT. This particular equation is useful when you are finding velocity. Sometimes we also need to find time. So we can write T is equals to V minus U divided by A. So this is sometimes required for derivations in later stage, we will see. These all three equations that you see, they all are nothing but first equation of motion. But this one is very popular because it has got a name. We call this velocity time relation. V for velocity, T for time. So this equation is also called velocity time relation. Okay, I hope it is clear. Now let us see how we can derive second equation of motion. So in order to derive second equation of motion, we need to just take care of small thing, and that is the distance. Let's say the object, the car goes from here to here. Okay, in this case, as you can see, distance and displacement is same. Distance is equals to displacement, right? Because the object is moving in a straight line and it is not even changing direction. So in this case, distance and displacement is same, and we are representing it as S. So when the object goes from initial velocity U to final velocity V in time t, it actually covers certain distance. So second equation of motion is going to give us the relation between displacement with the other quantities. But how do we find distance? From class 7 you are learning like distance is equals to, the formula for distance is speed into time, right? And similarly, if I have to ask what is the formula for displacement, well, displacement formula is also simple. Displacement will be equals to velocity into time. Velocity into time. Well, in this equation, we sometimes forget that this speed refers to the constant speed. This refers to the constant speed. This formula is applicable when the speed is constant, and similarly this formula for displacement is valid if this velocity is constant, right? But objects usually do not move at constant speed. For example, in this example of bus moving from point A to B, the speed was not constant. The bus was accelerating, means the speed was changing from 0, 10, 20, 30, 40. So what speed will you take? Will you take 10 or 20 or 30? That's the problem. So in that situation, what we are supposed to do, in order to find the distance covered by the object, we take average speed. What do we take? Average speed. Average speed into time. This is a formula to calculate distance if the object is in a non-uniform motion where the speed is not constant. And similarly for displacement, we can write displacement is equals to average velocity, and write average velocity into time. So how can we calculate average speed? You have learned the formula. Average speed is equals to total distance covered by total time taken. So I can write here total distance covered, and you have done lot of numericals based on this. Total distance covered by total time taken, and the formula you can write in symbols like d1 plus d2 plus d3, d1 represents the distance covered in the first interval, d2 represents distance covered in the second, and likewise. And similarly, t1, t2 is the time taken for each interval, t1 plus t2 plus t3. So this is your formula for average speed. Now, what is the formula for average velocity? Well, the formula for average velocity can be learnt as average velocity is equals to initial velocity u, whatever is your initial velocity u, and plus final velocity v divided by 2. Now this is initial velocity plus final velocity by 2. This formula is correct and applicable, but not in all situations. This is correct when the acceleration is uniform. When acceleration is uniform. Now this is something new for students of class 9, because you know what is uniform motion, where you say speed is constant. So what is uniform acceleration? What is non-uniform acceleration? Okay, this is an important concept that you need to learn before we get into the derivation, because if you understand the concept of average velocity, then you will get a mother equation which will help you to derive the other two equations. Okay, so let's understand in brief what is uniform and non-uniform acceleration. So let us see an example. Let's say this is the position of buses at different time intervals. Let's say at t is equals to 0, it is over here. At t is equals to 1, that is after 1 second, after 2 seconds, after 3 seconds, and after 4 seconds. The position of buses are given like this. Okay, and this is the velocity. Let's say the velocity is 0. After certain time, the velocity is 10 meter per second. Now the velocity is 20 meter per second. Now the velocity is 30 meter per second and 40 meter per second. So what do you see in this case? After every 1 second, the object's speed is increasing, velocity is increasing by 10. So here if you find see the acceleration, you'll find that acceleration is basically 10 meter per second per second. So it is 10 meter per second square. And again here, if you see the acceleration over here, that is again 10 meter per second square. So you find that acceleration is constant, and that is why it is called uniform acceleration motion, accelerated motion. And we are going to learn the derivation for uniformly accelerated motion only, where the acceleration is uniform. In this case, if you want to find the average, you can, let's say I want to find the average between A and B points. The average velocity will be initial, that is 0 plus 10 divided by 2, and that will give you 5 meter per second. That is the average velocity between point A and B. If I want to find it between point B and C, from B to C, average velocity is, initial will be 10 meter per second, final is 20 meter per second divided by 2, and that will be 30 meter per second divided by 2, and that is 15 meter per second. So likewise, you can take any two positions. Let's say I want to calculate for, this is A, B, C, D and E. So if I calculate for position D to E, what will be the average velocity? The initial velocity is 30, the final is 40. So this is 30 meter per second plus 40 meter per second divided by 2, that is 70 meter per second divided by 2, and that is 35 meter per second. So this is how we calculate the average velocity. But this is true for uniformly accelerated motion, where acceleration is constant. The rate at which acceleration is happening, that is not changing. But if the acceleration is not non-uniform, for example, let's say again this is time t is equals to 0, t is equals to 1 second, t is equals to 2 seconds, t is equals to 3 seconds, and t is equals to 4 seconds. And let's say the velocities are here 0, 10, and here it is 12, then it is 20, and then let's say it is 40. Now if you calculate the acceleration for the position A to B, let me write A, B, C, D, E. So if I find the acceleration for position A to B, the acceleration will be A is equals to V minus U by T, and that will be 10 minus 0 by time interval is 1 second, so it is 1, and that will give you 10 meter per second square. If you calculate the acceleration over here, this will be like 12 minus 10 by 1, that is 2 meter per second square. And for point C to D, if you calculate, it will be 20 meter per second minus 12 meter per second divided by 1, and that will be 8 meter per second square. So you find here that the acceleration is not constant, the acceleration is changing. Here it is different, here it is different, here it is different. So in such a situation, we cannot use the formula u plus v by 2 to find the average velocity. This formula is not applicable here. Okay, so we are going to learn all the derivations for uniformly accelerated motion, where you are giving the acceleration to the vehicle but in a constant manner. It's not like this happening like this. Okay, now let us see how we can derive. If you remember, this displacement is average velocity into time. This is the mother equation. From here we can derive both the second and third equation. So let us write over here. So in this equation, as I told, we are finding displacement here. This is your displacement. How much object moves before it reaches the position from A to B. So displacement we are representing as S, and this can be distance as well. Initial velocity we assume to be U, and final is V, and certainly it will take some time to go from A to B, and that we can represent it by T. Let's say it takes T time. Okay, so how can we derive the formula for displacement? So the formula for displacement, as you have already, like displacement is equals to average velocity into time. Okay, so this is the average velocity into time. So if I write here u plus v by 2, and this is into t, and displacement symbol is s. So this is the mother equation, and this equation is going to give you both equation 2 and 3. Okay, so how can we derive equation 2 and 3 from here? Let us see equation 2 that we have to derive. Equation 2 is s is equals to ut plus half at square. So children, if I ask you, in the second equation, which parameter or which variable is not present over here? Among u, v, a, t and s, you can see that v is not present in the second equation. S is present, u is present, a and t, these all are present, but v is not present, which means that I need to substitute the value of v. And we know from first equation that we have derived already, v is equals to u plus at. So if I substitute the value of v as u plus at and write the other equation, other things as it is, that is u plus 2 like this, and into t, that is, this will give us the second equation of motion if we simply multiply and solve further. This is u plus u will be 2u, and a plus at divided by 2, and the whole thing is multiplied by time t. So let us multiply further. So I will get here 2ut plus 8t in t into t will be like I'm writing like this, divided by 2. I can simplify this further as 2ut by 2 plus 8t into t is t square divided by 2. So you can see here 2 and 2, the common factor is cancelled out, and again we got the equation finally. So you can see here s is equals to ut plus half at square. Got it? S is equals to ut plus half at square. Children, please note here, it is t into t. So the square is not present on a, it is only present on t. Got it? So this is your second equation of motion. In order to derive third equation of motion, you just need to start from this equation and you will get the answer. So I'll rewrite the equation. To derive third equation of motion, as you know, the mother equation is displacement s is equals to u plus v by 2 into t. Now this is your equation, and what exactly we need to derive? We are deriving v square is equals to u square plus 2as, right? So in this equation, if you tell me like from u, v, a, t and s, which parameter is not present in the third equation? This is the third equation. So which parameter is not present? I hope you have figured out. It is the time. You can see time is not present in the third equation. So we need to substitute time from the first equation. So you know the first equation. From first equation, which is v is equals to u plus at, and if you just find what is t from here, we will get v minus u is equals to a into t, and we can write t as v minus u by a, which I have also shown you a little earlier. Okay, so if I substitute the value of t as v minus u by a, and this already we can write as v plus u, and we can write this as v plus u. I have done just a small change over here. Why? I'll show you. I have just written u plus v as v plus u. I have not made any more changes, and t is substituted by v minus u by a. You must have learned one formula in math like a plus b multiplied by a minus b. What is this identity? A square minus b square, right? So we can use this identity beautifully over here and see how maths helps us, in solving this question. So v plus u, v minus u will give you v square, and this will be minus u square divided by this 2 and a can be multiplied. This is 2a and this is s. So from here, if I again multiply and write it like this, 2as is equals to v square minus u square. And just now we can simply just do a small transposition here. We can send this u square to the left hand side. I will get u square is equals plus 2as is equals to v square. And to get this equation, we just have to change left hand side to right hand side, and hence you get the third equation of motion. So I hope you have got the three equations of motion. Its derivation is clear to you. Now for a quick summary, we can see and analyze the three equations of motion before we end today's session. So the first equation, as you know, is v is equals to u plus at. Second is s is equals to ut plus half at square, and the third equation is v square is equals to u square plus 2as. Now children, when you are getting into the numerical, the problem will be to figure out which equation to be used where. So for that we can do a small analysis here. What we can do, we know that all the equations are based on the 5 things like first is U, second is V, A, T and S. U stands for initial velocity, V final velocity, A acceleration, T time, S displacement. So let us do a small analysis. In the first equation, if you see here, okay, let's do it like this. Please see if U is present in the three equations. You'll find that U is common. U is present in first equation, second equation and third equation. U is present in all three equations. What about V, final velocity? Is it present everywhere? In fact, no. U is final velocity is present in first equation, but not in second equation, but present in third equation. Similarly, check for A. A is present in first equation, second equation and third equation as well. So A is present in all three equations. And time, if you see the time is present in first and second, but not in third. And what about the displacement S? S is not present in first equation, present in second and present in third. So here if you see, there is something that is not present in each of the equation. In first equation, displacement is not present. In second equation, velocity, final velocity is not present. And in third equation, time is not present. So if you are asked to find, let's say, final velocity, so you are not going to use the second equation because it is not present in the second equation. If you have to find time, then you will not use third equation. Okay, in that case other two equations are useful. Now further we can just summarize like this. If you have got S and T, if you have got displacement and time, then you should use the second equation. If time is not present, then don't use third equation, and if displacement is not present, don't use the first equation. Okay, so I hope this will help you to solve the numericals based on three equations of motion. Watch this video carefully, and whatever doubts are there, you can put that in the comment. I'll try to answer and simplify if required. Okay, that's all for this video, and we will see you in the next video. Until then, take care of yourself and happy learning. Bye bye, take care.